Okay, welcome back to the channel, but this time I have a timer so that I don't go on about irrelevant topics. So in this instance I'm redoing my agent to use different methods because I've spent some time figuring out how I can update the probabilities during an episode. An episode in this case is just a run of the game, and I've extensively made some calculations in order to figure out how exactly I want to do this, where I illustrate what I'm doing. So before I start writing the code, I'm going to explain what I'm actually doing. So in this instance we have a state, and in this state we have differences from previous states. We also have a cumulative sum, which is in this case these dots are -1 and this x is -100. So the difference from these two and these two is just 0. The state at this point is 3, and at this point I have these which I call buckets to make it easier to calculate the probability. And it's up, left, down, right. So this is up, this is left, this is down, this is right. So in this position, if we go down, we hit an x. So in this case, we hit an x, and our state looks now like this. It's S4. This is S4, and we have 2, 1, 2, 2. So we went up once. I'll explain why it's one more in a bit. We went up once, down 0 times, left 0 times, down once, and right once. The order doesn't matter. In this case, we just keep track of the total number of moves for each move. Each state has its own bucket like this, or each state has a collection of buckets like this. The sum here is -1, -2, -3, -103, because we hit the next. The rewards, I didn't know what letters to use. At this point we have gathered that at the first position we have -1, -1, -1, and we hit -100. So the differences between these first two was 0, 0, and this one's 99. So we know we can use this. And the modified state, the modified buckets for the last move down is 99 over 103, which is the cumulative sum. This can give us, oh, right here, I have written this somewhere. Using cumulative sum, we can make smaller adjustments. The more state we transition through. This may not be the best solution, so I have an alternative where I just take this one and divide it. Divide the difference by the reward, and we get -99, which is kind of what I want. We don't really want an absolute 0 there. So the next time we take the state, it doesn't, it reduces the probability by 99%. Here we go. If we go to the left, meaning we don't hit an x. And here I make the point that I could use the previous bucket on a new bucket. So what I mean by this is that these are previous buckets from the previous state. So we have one up, 0 left, 0 down, and 2 right. So up, right, right. And the starting bucket. And this is the base probability I want every state to have, because otherwise it would just be zeros. And we get this result. This is what I'm working with. The reward at any given point is 0 still, so the differences are 0, and the cumulative sums are also just increasing, or rather decreasing. The modified state, therefore, for this, or rather the previous one, where n is just n, we have the previous one, which was here, so that's just one less to the right, meaning that's just this point, this one. So the modification, there's no modification because there was no significant difference, and we found no rewards or anything. Here I've tried to make a point about how I update buckets. A represents an action, and basically I'm probably gonna ditch the math notation because I'm not even sure I'm writing this correctly. But in any case, I am trying to determine how to modify. So this was the difference, -1, because it's just because if we use this one, then we have to make sure the difference is always one less, so that's why. So the action for state n in bucket 4, the modification is, this is the modification, this entire thing, and a is just the absolute value of f, and f is just the difference. That doesn't really matter. It basically corresponds to the action we took. And here I've just made a few examples. So the first one doesn't get updated, it's -2, that's this one, that's where there's an arrow here. And here we have the fourth one, so this last one. For dn, for the differences, it will be the third one, because 1, 2, 3. And we go like this, and we modify nothing. The same thing we do here, except we actually hit something, so we modify it. For updating, I need to figure out, I need to explain how I'm going to do this. So here I have a little cloud, which represents the fact that at this point we should have a previous episode. So this is episode at index I, and this is one at index I -1, which means that this is the previous one. The positions here aren't that important because we don't really want to focus on positions. Here we have the difference of us hitting X right at the start, so that's why there's an X here, but that was previously. And we don't know anything about the rest of the tiles other than the one we were on and the one we were on now, plus the ones we visited in previous episodes. So here our cumulative sum was -102. So the sum of cumulative sums. Okay, the sum of sums here, right? Here is the attempt at me drawing the Greek symbol for sum. We add up all the sums from the previous day to get the score. It's not really that important, but this is just to keep track of what was better than the other one, basically, so that I can determine which episode was better. So it's just kind of like a score. It also serves as a good way to determine how much to modify something. Basically, I tried to gather as much information on this particular state as I could. and I'm starting to run out of time, so I'm probably going to split this up. But in the previous state, we have created the sum, and we determined that this position here, this x, wasn't the best decision. So we modify the previous one, which is here, the probabilities of this. We change by that amount. So that was just the starting bucket, basically, plus minus 99, which gives us this. And the probabilities for making any choice at that point is now updated to this. Meaning going right is very low. I think this was up, and this was left and down, I think. I'm not using a tablet right now, so that's why it's so weird. Here I've made the point of the new state getting combined with the starting bucket. So the next state is always, in this case, the previous state plus just the basic distribution I want to have to get starting probabilities. So if you have 4, they're equally important, so all of them are 1/4 probability of picking that action. Otherwise it would just, be 0/4 or something, so that's 0. So we wouldn't be able to make a choice. The way I calculate them is very simple. Where's some stuff? Those previous. Yeah, here we take the value we've made at that state, index I, and we calculate the probability of that just by dividing by the sum. Simple stuff. Nothing complicated. Here, this is the calculation, and we get the probabilities we want. Here I thought that the sum of differences would be interesting to have, but in this case it's just the last one. And in my algorithm, I really am just keeping track of the last one. I'm not actually building up arrays like this, but each state has the last sum. So that's why I'm probably not gonna use use this sum of sums. Although it's just simple, I just need to add them together during traversal. So the problem here I have right now is being able to, this is not actually what I do, being able to pick the right state from all the previous episodes. And because I'm running out of time, I'm going to split this off because I want you to go and do other things. And if you're interested, just stick around. There will be a part 2 to my ramblings. And I'm actually going to go over the programs I'm writing for this and illustrate what exactly it does. So I hope you liked the video. If you did, then like, subscribe, and check out my Patreon. So I hope you like it. If you do, then like it, and you can let me know in the comments what you want me to focus on. Right now, I'm kind of obsessed with reinforcement learning, and my time has run out, but I had to write this entire thing out because I needed to make sure I'm doing something right, or what I'm doing right, what I'm doing wrong, what I can expect, etc. So thanks again for watching. I'll see you in the next part.